Ciao friends! Using DAX, you can divide two numbers using two different techniques. You can use the regular slash operator that divides two numbers, or you can use the divide function, in case the denominator might be zero. Indeed, divide returns infinity if you try to do a division by zero, whereas divide always returns its third argument, which defaults to a blank. Now, whenever you have the option of doing something in two different ways, the natural question is which one is the best technique. You can find a lot of different answers. Somebody tells you that you always need to use divide no matter what. Somebody else says, no, division is better. In this video, I want to show you which one is the best, and we will do that by analyzing the query plan and understanding exactly the difference between divide as a function or the divide operator. Let's go straight to the PC and look at a demo. I have my regular Contoso model here with 12 million rows, and we want to evaluate the performance of divide. So we start by defining a measure. Let's define measure sales divide 1. And divide 1 is just an average, because we want some aggregator. We iterate over sales and we divide, let's take, for example, the average discount percentage. So we take the average unit discount divided by the sales unit price. And finally, we need to return a number. So we just compute div1. Now, we want to evaluate the performance of this measure. So we need to enable the query plan and then look exactly at the time it takes. Let's do that. We want the server timings, not the query plan. Let's wait for a while until it starts. And then we run the query. It was very fast. Let's zoom in a bit and also go in bottom layout. You see that the entire query took 29 milliseconds and 94 milliseconds of storage engine. Everything is running inside storage engine, and the entire calculation is carried on by storage engine. The XMSQL query that is executed casts the discount as int and then divides by 10,000 because it's a currency, so all the math need to be done with 4 decimals. And it's just computing the sum of the expression, where expression is the division of unit discount by unit price. So the division has been executed by storage engine and it took 29 milliseconds. Let's run it a couple of times just to have an average, 29, 19, 22, 21. Let's take this value. So if we just carry on a regular division, we take 21 milliseconds of total execution time and, most important, 94 milliseconds of storage engine CPU. Always remember that the storage engine CPU is the time needed in order to compute a number, whereas the execution time takes into account parallelism. So the two numbers are relevant, and you need to compare both in order to understand which one is faster from the user perspective and from the CPU usage point of view. Now, this calculation would fail in case a unit price is equal to 0. So we need to protect this code. And we can actually write a different version of the same code. It messed up everything. Where we check for the denominator. Let's write divide 2. We still don't know the time. Where we add an if statement saying, well, if the unit price is different than 0, then do the division. Otherwise, so if this is different than 0, do the division. Otherwise, return a blank. We need a bit more space here. So average divide 2 iterates over sales, and now it introduces an if statement. Is it going to be slower or faster? We have the feeling that it will be slower, but we don't know how much slower. So let's evaluate divide 2, run the query a couple of times. It went in 53, 50, 67, 59. Okay, let's take 59 milliseconds. 469 milliseconds of storage engine CPU. And the most relevant thing is that if we now look at the XMSQL query that is executed, we have a callback data ID. Indeed, the if statement cannot be executed by storage engine, so Formula Engine is involved. Still, the execution time went from 21 to 59 milliseconds. So the calculation required a callback data ID. Callback data ID are bad, but not all that bad. They are kind of good because parallelism is still involved. And the Formula Engine executed the if statement, whereas storage engine is just scanning the data. So from 21, we went to 59 milliseconds. Now it's time to take a look at divide, because the if statement protects us from division by 0, but divide does the same. So let's give divide a try by creating a third measure. We copy the first one and we create divide 3, where this time instead of doing the division, we divide one by the other. And then let's evaluate division 3. Let's run it to have an idea of the time needed. And now it's 43 milliseconds, 297 milliseconds of storage engine CPU. Let's run it a couple of times. Again. Oh, that was low. That is probably better kind of timing. 49, 328. So 49 milliseconds, 328 as the execution time. And if we look at the XMSQL query, you see that we still have a callback data ID that this time evaluates divide. So divide, like if, cannot be executed by the storage engine. It requires Formula Engine. So we still have a callback data ID. Performance is a bit better if you compare it with the if statement, but it is worse than a regular division. So, can we do anything better than that? Actually, we can, because if we guarantee that the denominator will never be 0, we can use a regular division, and we can guarantee that the denominator will never be 0 if we just remove zeros from the entire calculation. So we run a calculate up front that gets rid of any denominator that is equal to 0, and then we run a straight division. Let's do that. We can create a fourth version of the code. Let's copy again the first one, and we create divide 4. Now divide 4. We use a regular division, but this time we embed it inside calculate, and we check that the denominator needs to be different than 0. Different than 0. Then 0. Okay. How is divide 4 going to perform? We don't know that, but we can test it. We run it once, and it looks faster. We run it twice, 3 times. That is kind of consistent. 26, 172. And most relevant, if we look at the query plan, you see that there are no callback data ID. The entire calculation has been pushed down to the storage engine. So let's draw some conclusion from the numbers we have seen. 21 milliseconds is the time for a regular division, 59 if we use the if statement, 49 if we use average x over divide, and 26 if we use calculate to perform the division. So, does that mean that divide is slower than a regular division? Yes, it is. But it is also important to look at the code and understand exactly how much slower, because we went from 29 milliseconds to 49 milliseconds. The difference is really tiny. And besides, it's very unlikely that your code only contains one division, so an average x over a division, as I'm doing here. It is much more likely that your code is much more complex. So the presence of callback data ID is absolutely normal. And the difference of a few milliseconds in a division is not really relevant. If you can use calculate, then go for that, because that is going to provide the best performance. But when the code is more complex, then the choice is no longer so simple. For sure, a division is faster, but divide works just fine. So, which one is better? You know the answer, it depends. If you are really striving for perfection in order to find the best possible performance, then a regular division is the way to go. But divide is not that bad, so I would not be worried at all. The difference between divide and division is by far not the first thing that I look at when I need to optimize code written by anybody. Enjoy DAX!